Hi, welcome to this video. In this video, I will be talking about the laws of logarithms. A lot of us have learned about them when we were in the previous math courses, such as Algebra 2 and Pre-Calculus. In this video, I will show you guys how these laws come by. Alright, and I will also be showing a few examples on how to apply them. Okay, so let's start. The first one, if you have not already, if you haven't done so, please make sure you copy this the first one, 1, 2, 3, 4. Make sure you copy down the first 3, and I will show you guys how to get the fourth one later on. But you can go ahead and copy all 4 of them down and make sure you remember them so that you save time when you are answering questions, okay? Now, so just to show you guys how these laws work. So let's say today if I have log, say 2 plus log, say 5. If I don't have a base, right now I don't write the base. When we don't write the base, automatically the base is 10, okay? It is automatically 10. So this is log 2 to the base of 10 plus log 5 to the base of 10. I can simplify that as log 2 times 5, which is 10 to the base of 10, which gives us 1. And if you're a bit skeptical, go ahead and put that in your calculator. Put this in log 2 plus log 5. You should get 1. Alright, so let's look at the second one, second law over here. So if I have log x minus log y, that would be log of x over y. So let's take a look. So maybe something like if I have log maybe 200 minus log, say, 2. Right, log 200 minus log 2. Again, the base is 10, but we don't write that. Okay, so we don't write it. So if we don't write it, that means automatically the base is 10. That would be log. So according to the rule, I will have 200 over 2, which is log of 100. And since this is base of 10, right, the base of 10, so 10 to the power of what gives us 100? The answer will be 2. Okay? There's no need for any calculator. We can just use the laws to help us to find the answers without a calculator. Okay. Now the third one. So for example, the third one, if I have, say, log 3, and then I have, say, 27. This would be equal to, so I can manipulate the 27. I can change the 27 to 3 to the power of 3. Oh, you know what? Let me just change that. Sorry. I'll make that 81. Let's change this to 81. Right? So I'm going to manipulate the 81 here. So log 81 to the base of 3. I can change the 81 to 3 to the power of 4. Right? Which means right now my logarithm looks like that. It looks like that. So I can, and this says I can bring this end to the front, right? And they will look like this. If I bring the end to the front, I will have what I have. I will have the left hand side. So I'm going to bring this 4 to the front, and that's going to give me 4 log 3 to the base of 3, and that will give me 1. So my answer is just going to be 4. Okay. And the fourth one is actually pretty. The fourth one is more like an extension from 3, right? So if I have log a, and I have log 1 over x to the base of a, I can write this as log of x to the power of -1 to the base of a. And already when we were talking about the third law, I can bring this to the front. So that gives me negative log x to the base of a. Alright, so this is how we could use these laws to help us to evaluate the values, right? But in this video, I want to focus on how did these laws come by. And they are actually pretty interesting. Okay, so let's start with the first one. Log x plus log y is equal to log of x times y. So I'm going to start out by setting this x equals to a to the power of p, and my y is equal to a to the power of q. And if I convert them to log form, I'll have log x to the base of a is equal to p. Right? And if I convert this, this part, if we convert that to log form, I'll have log y to the base of a is equal to q. Right? Because remember, log always gives us the exponents. Right? Okay. Now, let's multiply x and y because we have x, y over here. So let's multiply x and y. So x and y becomes a to the power of p multiply a to the power of q. And since the bases are the same, I will have a to the power of p plus q. So my xy is equal to a to the power of p plus q. And let's try to convert this to log form. Okay, so my base is a, so I have a base of a, and I'm gonna have log xy, right? Log xy to the base of a is gonna give me p plus q. Log form always gives us the exponents. Right now my exponent is over here, right? So what's p plus q? P is over here, right? P is over there. P can be represented by that. So log p is equal to log x to the base of a, right? And q is over here, right? Q is over there, so I can replace q with log y to the base of a. So there you go. This is the rule, how the rule comes by. Okay, cool. Now for the division part, for the divide or minus, I'm gonna do pretty much the same thing. Okay, so let's try to set it up then. So I will keep a few. I'll keep a few things the same. I'll keep that the same. Keep that the same. This will also be keep the same. So the circled stuff will be the same. And now let's see what we can do. So let's go with x over y. So because I have x over y here, so let's do x over y first. So x over y would be a to the power of p over a to the power of q. Since the bases are the same, I can have a to the power of p minus q. Make sense? So x over y is equal to a to the power of p minus q. And we're going to change this to log form. Change that to log form. I will have log, my base is a, and here I'll have x over y, and my exponent would be p minus q. So the left hand side stays the same, and my p is log, p is over here, right? P is over here. So that would be log x to the base of a minus my q is over here, right? So log minus log y to the base of a. All right, so that's how the second rule comes by. All right, now next part. Let's see how this one works. To prove this, we have to be, the setup would be a little bit different. Okay, so still I'm gonna have x is equal to AP because I don't have so x is equals to AP, a to the power of p, I won't have any y anymore because there's no other terms, right? It's not unlike the previous two examples. I have one x, another y, an x, another y. I don't have that anymore here, right? So I don't have any of this. I just have x, right? I just have x. So I'm just going to say x is equal to a to the power of p. And I have this part. Oops. I have this x to the power of n. Let's try to see what happens. So if I have x to the power of n, that means I will have a to the power of p, the whole thing to the power of n. Make sense? And power to the power, we multiply the exponents. Okay, and now let's try to change that to log form. Okay, let's try to change that to log form. Let's see what happens. So I will have, wait, let me think about it. Okay, let's try and change this exponential to log form. I will have log, the base is a, and then the exponent that I'm interested in is the p and the n. So log a, I have x to the power of n, is equal to p times n. Okay, this is the exponent, this is the base. Right? Cool. And then let's see what we can do. So I have my p. Previously, my p is here. Right? My p is there. So my p is from here I get p is equal to log x to the base of a. So I can change that. That becomes n multiplied by log x to the base of a. So okay, so that's it. I just have to move the n to the front, and that will give me what I have on the right. All right, and that's it. So this is how the four rules, even though we have 4 of them, the last one is actually an extension of 3, right? The fourth one is actually an extension of the third one. Okay. Many of us know the rules, and the rules will help us to solve a lot of the questions, but not many people, not everyone knows how they came about. So I hope you guys find this video helpful, and I'll see you in the next video. Bye bye.